Hello everyone. Today we're going to learn how to solve a system of linear equations. So first off, what is a system of equations? Well, if you have a set of two or more equations, like x plus 3y is equal to 7, and let's say 2x minus 5y is 0, you can see I have two equations. As long as I have two or more equations, then I have something called a system. So this is a system of equations. Let me give you another example. Let's say we have x squared plus y squared is equal to 100. X minus y squared is 5. And let's say x plus y is 12. Here I have a system of equations. I have a system of 3 equations here, and this one had a system of 2 equations. Now, we don't have to just have 2 variables. We can have as many variables as we like. So let me give you another example. Let's say we have something like x plus y plus 2z minus w is 12. X plus 0y plus z minus 3w is 8. And how about one more? 2x plus y minus z minus w is 7. So this would be a system of equations. And it's actually a system of 3 equations in 4 variables. So I have 3 equations, 1, 2, 3, and I have 4 variables, x, y, z, and w. Those are our 4 variables. Notice something about this system. The powers on each one of these variables is 1. So we have x to the first power, y to the first power, z to the first power, and w to the first power. That's the meaning of the word linear here. If the powers on your variables is just 1, then you have a system of linear equations. We're going to focus on systems of linear equations where we have 2 equations and 2 variables. And then later we're going to talk about working with systems that have 3 equations and 3 variables. So an example of a nonlinear system would be something like x squared plus y is 7 and x minus y is 4. Because I have this 2 here on this x, it's not a linear system of equations. Again, a linear system means that every variable you see in any of the equations has a power of 1. We're going to talk about finding solutions to a system of linear equations. So here I have the ordered pair 1, 1, and I want to know, is it a solution to the following system? So here I have a system, I'm going to write it over here. A system, in fact, let's call it a linear system. Of 2 equations in 2 variables. See, their 2 variables are x and y, and we have 2 equations. What it means for something to be a solution to the system, that means when I plug in these values for x and y, here I have x is 1 and y is 1. When I plug them into both equations, I get a true statement. So you can see when I plug in 1, 1 into the first equation, I get 1 plus 1 is equal to 3. Or in other words, 2 is equal to 3, and that's not a true statement. So since it's not a true statement, it is not a solution to the system. So again, a solution is an ordered pair or a set of ordered pairs that satisfies both equations so that when you put them in for x and y, you get a true statement. If we don't satisfy one of the equations, then we don't satisfy the system. So I don't even need to check the second one. I can, you can see that I get -1 plus 2 is equal to 6, or in other words, 1 is equal to 6. That's not a true statement. So again, this is not a solution to the system. Here I have the same system, but I want to know, is this ordered pair 1, 2 a solution to the system? So all we have to do is plug in this point into the values for x and y. So for the first one, we get 1 plus 2, because again, this is our x, this is our y. Does that equal 3? Well, that's a true statement. Now let's try the bottom one. -1 plus 2 times 2, is that equal to 6? Well, I get -1 plus 4, which is equal to 3. Is 3 equal to 6? The answer is no. So this point is not a solution to the system. It satisfies one of the equations, but not both. And since it doesn't satisfy both, it's not a solution. Here I give you the point 0, 3. I want to know if it's a solution to the system. So again, I'm going to do the same thing I did for the last couple of problems. I'm going to plug 0 in for x and 3 in for y and see if I get a true statement. I need to plug them into both equations. So for the first one, I get 0 plus 3. Is that equal to 3? The answer is yes. Is -0 plus 2 times 3, is that equal to 6? Well, here I get 0 plus 6. That is 6. So the answer is yes. So this is a solution. So for each one of these problems I just showed you, I gave you this system, and I was actually giving you points and asking you, are these solutions to the system? So let's say I give you a system and I ask you to find all the solutions. You wouldn't want to go and plug in every single point you can think of, because you might not find the solution. So we're going to look at some ways to find the solution of a system. And we're going to talk about how many solutions a system can have. Again, we're going to focus on linear equations, and we're going to solve systems that have 2 linear equations and 2 variables. And normally the variables are going to be x and y. But you can substitute these variables with any other letters. You could have a and b, or you could have something like s and t, any other variables you want, as long as you have 2 variables and 2 equations and they're linear equations. So the powers on each one of these variables is 1. So how many solutions can such a system have? Now let's think about this. Let me just give you a random example. X plus y is 5 and x minus y is 3. Now, if we're looking for solutions, that's what it means to solve a system. So to solve a system, that means find all the ordered pairs that when we plug in those values for the ordered pairs, we get a true statement. So when we plug in the values for x and y, we get a true statement for both equations. So how can we do this? How can we find all the ordered pairs that satisfy this system, the system right here that I've given you? So once we figure out how to solve this system, it's going to be the same for all the other examples you're going to see. So let me erase this. Well, let's think about these equations here. Let's start with this first one. X plus y is equal to 5. I'm going to write it down here. Notice that if I move the x to the other side, I get the equation of a line. In fact, this is something really easy we can draw. This equation has a slope of -1 and a y-intercept of 5. So we're going up 1 over 1. So the graph looks something like this. And if we only had one equation, and I wanted to find a solution to that one equation, that would just be all the ordered points that satisfy this equation. So any point on this line would be a solution, because if you would plug them into this equation, you plug this in, you'll get 5 on the left-hand side. Now the other equation, x minus y is equal to 3, is also a line. So if we move the y over, we get x minus 3 is equal to y. If we move that 3 over, flip it, you get y is equal to x minus 3. So this is an equation of a line. It goes through 3, so somewhere around here, and the slope is 1. So our first option when we want to solve a system is to graph the system, because if we have linear equations in two variables, then we can graph them in the xy plane. And a solution would be where these two lines cross, because that would be the set of all points that lie on this line and also lie on this line. So you can see right here, for this particular problem, these two graphs intersect at one point, and that will be the solution. So our first option when we want to solve these types of problems is to graph the two equations and just find where they intersect. All right, let's erase this. So let's write that there's 3 different ways that we can solve this type of linear system. Let's clean this up a little bit. So there are 3 ways to solve a linear system. And here again, we're focusing on systems that have 2 equations and 2 variables. The first way is to graph the system. So you're going to have 2 lines, and what you're going to do is see where they intersect. The second method that we're going to look at is something called substitution. And what you're going to do here is you're going to solve for one of the variables in one of the equations and plug that variable into the other equation. And we're going to see examples of this. Let me look back up here at this problem. What you would do is you'd pick your favorite variable. You could x or y in either one of these equations. So let's say we go with this first one. We solve for x, so we get x is equal to 5 minus y. And then you take this x, you see it in this equation here, and you plug in 5 minus y there. When you do that, then you're just going to have an equation involving one of the variables. When you have just one variable, you can solve for it. And then once you know what y is, you're going to plug that value into the first equation. We're going to do plenty of examples of this. Right now, I just want to tell you and just give you a brief description of each way to solve this linear system. So the second method is substitution. And the third method is what we call elimination, and some books call it addition. And what you do for this problem you add multiples of the equations together to eliminate one of the variables. I'll show you how to do that. For example, in this problem right here, notice that if I add these two equations together, I'll get 2x, the y will disappear, and I'll have is equal to 8. Then I can solve for x, which I will get x is equal to 4. And then to figure out the y value, you just plug that x value into either one of these equations. It doesn't matter which one. And then you use that to find y. So if I plugged in 4 here, I would subtract 4 from both sides and I get y is equal to 1. So I have the point 4, 1 that satisfies this problem. Notice that if I put 4 plus 1 here, I get 5, and 4 minus 1 is equal to 3. So that is the solution. Okay, now what I want to talk about is, before we look at each type of way to solve the problems, what I want to do is I want to figure out how many solutions a system can have. Okay, right here, this particular problem is going to only have one solution. But is it possible for a system to have more than one solution? Okay, suppose we have this system here. I have a system of 2 equations and 2 variables. And this A, B, C, D, E, F, so A, B, C, D, E, and F, they're all real numbers. So they can be anything you want. So for example, something like this. We could have like 2x plus 3y is equal to 7. And what we would need to do to graph this is we would solve for y. So if this was the particular problem, this first equation, we had this one. Let's say 2x plus 3y is equal to 7. What we would do to solve for y is we would move the 2x to the other side and divide by 3. And then we could graph this because this is the slope and this is the y-intercept. So what I'm doing here is I'm trying to be a little more general. I'm going to let this work for any A, B, and C and any D, E, and F that you choose. We know how to graph this. So we would just move the part with the x to the other side and divide by this coefficient, this B and this E here. So what could happen when we graph this? So we're trying to find solutions. There's actually 3 different things that could happen. So our first line, when we graph it, could look something like this. And the other line could look something like this. Of course, they could intersect somewhere else. The slopes could be different, but this is the overall idea. We have 2 lines and they intersect at one point. And that point, you can see, is right here where they cross. When this happens, this is called a consistent system. And the equations, you'll see this sometimes, are independent. And that means we're going to have one solution to the system. That solution is this point right here. Whatever that point is, when you find it, when you see where those two intersect, then that's what you're going to write as the solution. Now, can 2 lines intersect in more than one spot? The answer is yes, but if they intersect at more than one spot, they intersect at infinitely many spots. And that's because something else that can happen is that this first equation gives you the equation of a line, and the second equation gives you the same line. And those 2 lines lie on top of each other. So when the two lines lie on top of each other, this is a consistent system. And the equations are dependent. And you're going to have infinitely many solutions. Because every single point, like this point right here, is going to lie on both graphs. So this point here is going to lie on both graphs. This point here is going to lie on both graphs. So you can cross, if you're the exact same line, then every point is going to be a solution to both equations. Let me give you an example of something like this. So if you had something like, let's say x plus y is equal to 2 and 2x plus 2y is equal to 4. Notice I just doubled this equation here to 2x plus 2y is equal to 4. And so they're the same exact line. If you solve for y for this equation, you're going to get the same thing that you get when you solve this one for y. So it's the same line. So they're going to intersect infinitely many times. So right now we saw that when we're looking for solutions of a system, we can have one solution or infinitely many solutions. There's also a third option, and that's when you have no solutions. When do you think you're going to have no solutions? What kind of lines would these be? So you're going to have an inconsistent system, which means you're going to have no solution. And that happens when you have parallel lines. Okay, so parallel lines, you would have one line look something like this, and then one line looks something like that. An example of this would be this x plus y is equal to 2, and then we could also have x plus y is equal to 3. So you can see that we have two things being added. They have to equal 2, but at the same time, when I add the two things, they're equal to 3. So this would be an example of when we have parallel lines. Again, if you solve for y, you can see that the slope of the lines are going to be the same. It's going to be -1, but the y-intercept is different. And because the y-intercepts are different and they have the same slope, they're going to be parallel lines. So these are the three options you're going to get when we see solutions, when we see systems. When you see a system, you're going to either say one solution, no solutions, or infinitely many solutions.